Hey everyone! In this video, I'd like to talk about the prime factorization of a number. Now, before we can talk about the prime factorization, there are a couple things we need to know. One, we need to know what a prime number is, and two, we need to know what factors are. So let's start with factors. Now, a factor, if I'm given a number, the factors of that number are any numbers that, when multiplied together, give me that original number. So let's start with just an example of a number, and then let's take a look at the factors of this number. So, for example, let's just take a look at the number 12. So with 12, any numbers that when I multiply them together, if they give me 12, these are factors. So for example, 1 and 12 would give me 12. 2 and 6 would give me 12. 3 and 4 would give me 12. And those are all the combinations. So 12, the factors, if I list all these off, I have 1, 2, 3, 4, 6, and 12. So those are all the factors of 12. It's all the things that when I multiply them by some other number, I get 12. The other way I could think of that is 12 can be divided by all of these. 12 is divisible by all the factors. So I can take 12, I can divide it by any of these numbers, and I end up with a whole number. Okay. The other thing to note here is how they pair up. So 1 and 12 go together, 2 and 6, 3 and 4. Sometimes when we have a perfect square, like 9, we have a repeat in the middle. So the factors of 9, we have 1 and 9. When those are multiplied, we get 9. And in the middle, we would have 3 times 3. We don't have to list the 3 off twice, but we only have an odd number of factors for this perfect square. The second thing we need to know is what a prime number is. So a prime number, these are numbers that the only factors are 1 and itself. So there's nothing else that it can be divided by. So the first couple primes, we start off with 2, which is actually the only even prime, 3, 5, 7, 11, 13, so on and so forth. So these numbers, their only factors are 1 and the number itself. Notice I didn't put 1 down. 1 only has one factor. The only thing 1 can be divided by is 1. To be prime, you need the 2 factors, and exactly 2. You need 1 and itself. Okay, so now that we know these two things, we can talk about the prime factorization. A prime factorization, we are going to take a number and we're going to break it down into a product of only prime numbers. So let's start with a really simple example. So let's take the number 12, and I want to write this as a prime factorization. So we want to write it as a multiplication of only prime numbers that when we multiply all of them together, we get 12. And I think a really easy way to do this is with a number tree. So let's just start by breaking down 12. I can start anywhere I want, but I want to get down to some smaller numbers. So I know 12, that's the same as 3 times 4. So we'll take 12, we'll break it down into these two numbers. Okay, 3 is a prime number, so I can stop with that one. But 4 is not a prime number, so we need to keep going. 4, that's the same as 2 times 2. So we can break that down. And now these are both prime numbers as well. So once I get to this point where all of these are prime, that's my prime factorization. So if I take 2 times 2 times 3, that is going to give me 12. So another way I can write that, just to make it a little bit more condensed, 2 times 2, that's the same as 2 squared. So my prime factorization is 2 squared times 3. Now, the really nice thing about prime factorizations is these are unique for every number. Okay. All right, so that was a pretty simple example. Let's take a look at a couple that are a little bit more complicated. So let's take a look at the number 132. So we need to break down the number 132. Again, we can start anywhere we want. So when I look at this, the first thing I notice is this is an even number. So this should be, I should be able to divide this by 2. So 132, if I divide that by 2, what I'm left with is 2 times 66. So I can break down 132 like this. Now 2 is a prime. If I look at 66, I need to keep going. Also even, so I should be able to divide that by 2. So 66 is the same as 2 times 33. So we'll break it down like that. And there's another prime number, 2. And 33, we can break that one down as well. 33 is the same as 3 times 11. And then 3 is a prime number, and 11 is a prime number. So now we're done. And now we just need to list those off. So 132, this is the same as 2 times 2 times 3 times 11. Or I can write that as, there's 2 2's here, so I can write this as 2 squared times 3 times 11. And let's just do one more. Do a little bit of a bigger number. So let's take a look at the number 240. Okay, right away, 240 is an even number, so maybe we want to start with the number 2. I could also start by breaking it out. I know it's a multiple of 10, so let's start with that. So this is the same as 10 times 24. So we'll break it down like this. Now, neither of these are prime numbers, but we can break down each one. So 10 is the same as 2 times 5. So breaking 10 down, now 2 and 5, these are both prime numbers. Got to work with 24. 24, this is the same as 2 times 12. All right, here's another prime number, 2. And then 12, we need to break down. And we actually already broke that down over here, so we can see exactly what we need to do. We can break 12 into 3 and 4. And then lastly, we can break 4 down into 2 times 2. So 3 is prime, and both of these 2's are prime. So now everything I have circled, those are my factors for 240. So 240, this is the same as, all right, I want to count how many of each I have. So I have, I'm just going to mark these so I don't lose track of any. So I have, here's 1, 2, here's the second one, 3, and so I have 4 2's. So that's the same as 2 to the 4th. There's only 1 3, and there's only 1 5. So 240 is the same as 2 to the 4th times 3 times 5. And that's how you find the prime factorization of a number. Thanks.